All right, welcome back. We are going to get started talking about the information needed for example 3. So, for example 3, to find the sum of interior angle measures of a convex polygon, right? Those are polygons that aren't concave, okay? So, to find the sum of the interior angle measures of a convex polygon, draw all possible diagonals from one vertex of the polygon. So here we look at this triangle, and if we were to take this vertex, there are no diagonals, right? So, but let's look at this quadrilateral. So if we had the quadrilateral here, we took this point, we could draw one diagonal, right? What about here? Well, we could draw a diagonal here, and we could draw a diagonal here, right? And those are all of the diagonals we can draw from this vertex. What about this vertex here? Well, we can't draw one there, right? Because those are consecutive. But we can draw a diagonal there, here, and here. Okay? So, to find the sum of the interior angle measures of a convex polygon, draw all possible diagonals from one vertex, like what we did, right? Draw all possible diagonals from one vertex of the polygon. This creates a set of triangles. Let's look at that. This creates a set of triangles. Well, how many triangles do we have here? We just have one. But look here. We have 2 triangles now, right? So there's one triangle here, and there's another triangle there. What about here? Well, we have 1, 2, 3, right? And what about here? 1, 2, 3, 4. Isn't that interesting? We have one triangle here, and then we have 2, and then we have 3, and then we have 4. I bet with what was this? A triangle, quadrilateral, pentagon, hexagon. How many triangles do you think there will be with a heptagon, right? That has 7. If it was 1, 2, 3, 4, it's probably going to be 5, I bet you. Seems like there's a pattern emerging. So let's look here. It says the sum of the angle measures of all the triangles equal the sum of the angle measures of the polygon. So this says the sum of the angle measures of all the triangles equal the sum of the angle measures of the polygon. Well, that makes sense for this one, right? It's just basically saying, hey, if you add up all these angles of a triangle, then it's going to be the same. We're talking about the interior angles. It's going to be the same, right? Well, it's a triangle, so 180, right? Remember, by the triangle sum theorem, the sum of the interior angle measures of a triangle is 180. Do you remember that triangle sum theorem? So that means 180. But what about here? So if we wanted to figure out what all those interior angles, if we think about how many triangles, well, there's one triangle, so all those interior angles is going to equal 180. And then there's another triangle here, which is going to be 180. So it's going to be 180, 180, or 2 times 180, right? What about here? There's going to be 180 there, 180 there, 180 there, because there's 3 triangles, or 3 times 180. And then what do we have here? 4 triangles, so 180, 180, 180, 180, or 4 times 180. And so if you can see, there starts to be a pattern. And we kind of started to see that, right? With the number of sides, 3 for a triangle, there's 1 triangle. Or 1 times 180 is 180. For a quadrilateral, there's 4 sides, and there's 2 triangles, and it's 2 times 180, right? And that's 360. That means all of those interior angles here for every single quadrilateral is 360 degrees. Just like for a triangle, it's 180. All of those interior angles for any quadrilateral, whether it's a rectangle, square, trapezoid, parallelogram, they always add up to 180 degrees. Let's see, what about this one? A pentagon, it says has 5 sides. There's 3 triangles, 1, 2, 3, and so it's 3 times 180, or all of the interior angles add up to 540. And a hexagon would be 4. I mean, there's 6 sides, right? Hexa means 6, so there's 6 sides. And then the number of triangles are 1, 2, 3, 4, so it's 4 times 180, or 720. That's how many degrees there are in the inside. So we went from 180, 360, 540, and 720. And then as you move up, an n-gon here which has n sides, look at the relationship. 3, 1. What's, well, 4, 2, 5, 3, 6, 4. What's the relationship here? Well, it looks like it's smaller, right? It's smaller by how much? Well, 3 and 1, that's 2, right? So 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So if we have n, the number of triangles is going to be n minus 2. And then whatever that number is, right? Because it was 1 times 180, 2 times 180, 3 times. So it's whatever this number is, 4 times, then you multiply that by 180. So if the number here is n minus 2, then it's going to be n minus 2 equals 180. And that's really the formula for the sum of the interior angle measures of all polygons is right there. And so that's it. In each convex polygon, so not concave, right? In convex, the number of triangles formed is 2 less than the number of sides. That's right here, 2 less than, right? So the sum of the angle measures of these triangles is n minus 2, the quantity n minus 2 multiplied by 180. So this is the formula. This is a flashcard, all right? I need this to go into a beautiful flashcard. Beautiful, beautiful, beautiful. So this is called the Polygon angle sum theorem. We're going to be using this a lot. The sum of the interior angles of a convex polygon with n sides is the quantity n minus 2 times 180. All right, let's go ahead and see how this works. So let's look at an example problem here. It says, find the sum of the interior angle measures of a convex heptagon. So it has to be a convex, right? Hepta, do you guys remember what that means? 7. So we're going to use our formula, which is n minus 2, the quantity n minus 2 times 180. That equals the sum of the interior angles, which is what we're looking for. And n is going to be hepta, so n equals 7. So then we just substitute in. And this really is very similar to some of the warm-up problems we were doing at the beginning of the lesson. Order of operations, we do this, right? 7 minus 2 is 5 times 180. I don't know what that is. I'm going to go 180 times 5 over here on the side. 5 times 0 is 0. 5 times 8 is 40. Write the 0, carry the 4. 5 times 1 is 5 plus 4 is 9. So 900 degrees, that's how many degrees there are in a convex heptagon. Every convex heptagon has interior measures of 900 degrees. All right, perfect. Let's go ahead and look at this next one. So this one says find the measure of each. Ooh, let's look at that. Okay, so this says you have to understand. This says find the sum of the interior angles of a convex. So this is like total. The sum of all of the angles. You're finding the total. That's what it's asking you to do. It's asking you to find, oh man. Okay, so it's the sum of the interior angle measures of a convex. So that's the total. So if you have a heptagon, right? 1, 2, 3, 4, 5, 6. This is going to be tricky to make this. 6, 7. Well, that's not convex, that's concave now. That's concaving in. Okay, let me try to draw another heptagon. That wasn't very good. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, whoops, sorry about that. Okay, so that is... We'll kind of make it go up a little bit more like that. Okay, so that is a heptagon. So when you're finding the total, that means you're finding this angle measure, this angle measure, this angle measure, this angle measure, all of the interior angles, right? And you're adding all of those together, and that equals 900 degrees. Okay? So this is the total. It's the sum of all of them, all right? And that's what this formula does. This tells you the sum of all of them, all right? Now, this is asking for something different. This is asking you to find the measure of each interior angle. Do you see the difference? This wants the sum of the interior angles, which is all of them. This just wants each interior, this just wants one. It just wants one angle. That's it. So you're going to have a regular 16 gone. So regular, remember what that means? All these words mean something, right? Regular means that all of the sides are the same and all of the angles are the same. All right? So this is a regular 16 gone. Okay? We just need to find one angle. So this is kind of like a two-step process. So the first step is you find the sum of all of the angles, like using this formula up here, right? So you're going to find the sum of all of them. And since it's a regular, that means all of the angles are the same. So once you have the sum, you have the total, then you just divide that total by 16, and then that will tell you how much one angle is, one of the interior angles. Okay? So let's just go ahead and do that. So we're going to put our formula here. We got the quantity n minus 2 multiplied by 180, and it's a 16 gone, which means n is equal to 16. Right. So then we just substitute it in. We get 16 minus 2, order of operations. We got to do the parentheses first. 16 minus 2 is 14. 14 times 180. I really don't know. I'm going to do it over here. 180 times 14. That's going to be 0. That is going to be 4 times 8 is 32. Write the 2, carry the 3. 4 times 1 is 4, plus 3 is 7. Now we're to the 10, so we got to put a 0 in the 10, the 1 spot. 1 times 0 is 0. 1 times 8 is 8. 1 times 1 is 1. And 7 plus 8 is 15. Write the 5, carry the 1. And then we got 2. All right? So that is the total of every single angle in a regular, right? All the sides and all the angles are the same, is 2,520 degrees. That is a lot of degrees. So that is the sum, right? But we just want one of those. So to find each interior angle, if there's 16 angles, right? If all 16 angles add up to this amount and they're all the same, then if we just take this number divided by 16, then that will tell us how much one angle is. And that's what we're going to do. So we're just going to go, we're going to divide this by 16. 16 doesn't go into 2, doesn't go into 25, but it does go into 252. I just don't know how many times. No, 16 goes into 25. I'm tripping. One time. 1 times 16 is 16. Yeah, 15 minus 6 is 9. Okay. 16 goes into 92. Sometimes, I like to make the numbers easier. So, make this a 15 and, make that a 90. And so I think, okay, how many times does 15 go into 90? So 15, if you add another 15, it'd be 30, and then it'd be 45, and then 60. So that would be, okay, so 15 would be 1, 30, 45, and then what's the other one? 60, and then it would be 75, and then it would be 90, okay? So if it was 50 going into 90, it would go in 6 times. But 16 is bigger. It's 1 bigger. So that means and this is really close to 90. So it's not going to go 6 times. It's going to go 5. If it went 6, it would be over 92. So then we multiply 5 times 6 is 30. Write the 0, carry the 3. 5 times 1 is 5, plus 3 is 8. Then we subtract. 2 minus 0 is 2. 9, take away 8 is 1. Then we drop it like it's hot. That's a 0. And how many times does 16 go into 120? So if it goes in to, whatchamacallit, 85 times. So what would it be? It would be 80, would be 5. And then 6 would be, if I'm going to think about this as, 15 again. So if it was, okay, this was 80 and it went in 5 times. And then 15 plus that would be 95. That would be 6 times. And then 95 plus 15 would be, what would that be? 95 plus 15 would be 110, right? And then maybe, so 7. I feel like I did something wrong here, because I feel like it should, well, maybe not. Maybe it will be a number that's not even. Let's see here. Oh no, I guess it is, okay, so it doesn't go in evenly. All right, so what do we say, 7 times? So we're gonna put it 7, 7 times 6 is 42, write the 2, carry the 4. 7 times 1 is 7, plus 4 is 11. And then we subtract, that's just 1, so it's 0. And then we have a remainder, so we're gonna add our decimal there and drop down, drop it like it's hot, drop it like another 0. And we know that 16 goes into 80 5 times. 5 times 16 is 80. So there we have it. There is each individual angle is 157.5 degrees. Okay, you guys see that? Very cool, very cool. Okay, let's look at the next problem. It's kind of like we're talking about the same concept, but we're just kind of like looking at it from a different perspective. Okay, so let's look at this problem here. This looks like a fun one. What does it say? It says, find the measure of each interior angle of the Pentagon. Oh, okay. So what do we have here? We have every single angle, but it's their algebraic expressions, right? So we know that all of these add up, right, to the sum of the interior angles. So we know that we're going to have 18C plus 32C plus, so 18C plus 32 plus 32C plus 18C plus 35C, right? So that's 18, 32, 32, 18, 35, okay? And this is going to equal the sum of all of the interior angles added up. So we have to use our formula to figure out what that is, right? We can do that. So I'm just gonna kind of work over here just for a second. And our formula is the quantity n minus 2 times 180. And n is, this is a 1, 2, 3, 4, 5. So it's a pentagon, so n equals 5. We substitute it in. We get 5 minus 2 times 180. 5 minus 2 is 3. And 180 times 3 is, I don't know. 3 times 0 is 0. 3 times 8 is 24. Write the 4, carry the 2. 3 times 1 is 3, plus 2 is 5. So it's 540. So that's what this equals. So all of these added together is 540 degrees. Okay? So it wants us to find the measure of each interior angle. So we have to find the measure of each of these. So if we set up an equation, right, all of these added together equals 540, combine like terms, figure out what C is, and then substitute back in, we should be able to figure this out. So let's do it. All right. So we have a lot of numbers here that we need to add up together. Yeah, sometimes I like to just count up the tens. So like there's 10 and this is 30. There's 30, there's 10, and there's 30. So that's like 10 and 30 is 40, and 40 plus 30 is 70, and 70 plus 10 is 80, and 80 plus 30 is 110. So I'm just going to write that. So that I'm going to check myself. So 10, 30, that's 40. 40 plus 30, 70. 70 plus 10 is 80. And 80 plus 30 is 110. Perfect. And then I want to look at count the ones and see if there's groups of 10. So if you see 8 plus 2, that's a 10. And then 8 plus 2, so I'm counting up the ones, right? That's a 10. So that's basically 10, 20, and then 5. So it's 25 is 0 plus 5 is 5, 1 plus 2 is 3, and 1. So all of this equals 135C. So sometimes that's how I add like a whole bunch of numbers, or you could just like write them all down in a big list and then add them that way. Yeah. Okay. So now we just need to figure out what C is. So I'm going to divide both sides using that division property of equality by 135. That becomes 1. We have C equals, and I'm going to say that, I don't know, how many times does 540 go in, 135 go into 540? I'll take it over here. Let's see here. Maybe if I think about this as like, maybe like 150. So if this was 150, and then plus another 150 would be 300, and then another 150 would be 450, and then another one would be 450 would be 600, which would be 4, but that's 150 and 135 is less than that. So I'm just going to figure out what 135 times 4 is. 4 times 5 is 20, write the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. 4 times 1 is 4, plus 1 is 5. Oh, 540. Perfect. So we know it goes in 4 times. So that means C equals 4, okay? So now we just need to figure out what each angle measure is. So let's start with A, right? So the measure of angle A equals 35C, and, you know, C is equal to 4. So that means it's going to be 35 times 4, which is, what is 35 times 4? 4 times 5 is 20, write the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. So, 140. So measure of angle A is equal to 140 degrees. Okay. Let's do the next one. So B, I'll change the color. Measure of angle B is equal to 18C. C is equal to 4, so it's going to be 18 times 4. I don't know what that is. 18 times 4. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. So 72. 72 degrees. So measure of angle B is equal to 72 degrees. And we also know that E is, it's 18C, so that's going to be 72 as well. But let's do them in order. So C, measure of angle C is going to be 32C. So it's going to be 32 times 4. Not sure what that is. 4 times 2 is 8. 4 times 3 is 12. 128 degrees. So we have the measure of angle C equals 128 degrees. And then D is going to be the same. Wait, whoops. So measure of angle D is equal to 128 degrees. And then measure of angle E is going to equal 18C, which is 72 degrees. And there we have it for 3C. So that's each individual angle, okay? That's how you find those. All right, now it is your turn to check it out. So I want you to try 3A and also 3B. Here is my friend, the Pause Dragon. Remind you to pause your device. Go ahead and work out those 2 problems. When you get done, press play and we'll go over them together. All right, see you in a bit. Okay, let's see how you did. So this first one says find the sum of the interior angle measures of a convex 15gon. So remember to use that formula. It has to be a convex figure. So we're going to use our n minus 2 multiplied by the quantity 180. That tells you the sum, right? Those keywords. We're finding the sum, so we're finding all of the interior angles added together, right? And n is equal to 15. So we just substitute that in. 15 minus 2 is 13. Then we just got to do that really quick. That's 0. 8 is 24, that's 5, and then 0, 8, 1, 2. Okay, so you should have 2,340 for the sum of all of the interior angles. Is that what you got? If you did, great job. Okay, let's go ahead and look at this next one here. What are the keywords on this one? This one says, find the measure of each interior angle of a regular decagon. Okay. So we're finding the measure of each interior angle. That means we're just finding one angle, right? And they're regular, so that means they're all going to be the same. So if you find one angle, you really found the measure of each of those, because for regular, all the sides are the same and all of the angles are the same. Okay? So remember, this is a two-step process. We have to find the sum of all of the interior angles, right? So we're going to use our formula in the quantity n minus 2 times 180. And a decagon, what is a decagon? A decagon, I want to say that's 10, right? A decagon is 10. Yes, it is. Decagon is 10. So n equals 10. So we substitute that in. We get 10 minus 2. 10 minus 2 is 8. Okay, got to figure that out. 180 times 8. That's 0. 8 times 8 is 64. Write the 4, carry the 6. 8 times 1 is 8 plus 6 is 14. 1,440. Okay, that's the total, right? But we need to find each. So we're just going to take that number and then divide it by the 10 angles, because it's all, you're adding up all 10 angles to get this number. So it's going to be 140 divided by 10. I'm just going to write it like that because it's super easy. You just cancel out the zeros and you end up with 144 for each interior angle. So if you got that one right, you did a wonderful job, and I'll see you in a little bit for example 4.